All right, everyone. Welcome back to another episode of CASA Choices. Thank you all for logging in and being here today. We do have something a little bit different today. Instead of our usual one speaker, we have a panel of engineers that we're so excited for you to hear about. And I'm going to pass it along to them so that they can introduce themselves.
Hi, my name is Lisa, and I'm also a CASA volunteer, actually, and Bianca is my supervisor. I am a chemical engineer, and I work at Caterpillar. Samia, if you want to go.
Yeah. Hi, I'm Samia. I'm an electrical engineer. I work for Caterpillar, and I have 2 little kids, and I've been working and chugging away at home for the past year.
And hi, I'm Nicole. I work at Caterpillar, and I am a mechanical engineer.
Okay, I'll go next. My name is Ursula Town, and I'm a mechanical engineer, and I also work at Caterpillar. I work in engines, and I've worked there for just about 20 years.
Adam, do you want to go ahead and introduce yourself? Or Sam?
Yeah, I can hop in next. I'm Sam Chadwick, and I'm a little bit different from everybody else, not a engineering degree person, but I am a service tech rep at Caterpillar. So, yep.
Thanks, Sam. And then Adam, you want to introduce yourself?
I'm wondering if maybe Adam's having some technical difficulties. So we'll go ahead and move on from him. And if he does figure out his microphone, then we will do his portion then.
That's fine. All right. Ursula, if you want to go ahead and share your screen. See if this works how we intended. Okay. Okay, great. So you've heard all of us, and we are here to talk to you today about different engineering and technician careers and for CASA Choices. And as we just mentioned, we're a mix of chemical, electrical, mechanical, and the Think Big program, in addition to laboratory technician at Caterpillar. Let's see. I'm not forwarding. There we go. Okay. So we just talked about that. We can probably go on to the next one. So a little bit about me. I grew up in Jackson, Michigan, which is shown here on the map, the mitten. And I went to school first at a community college for 2 years, which was a great way to do that. Oh, I did not do that. Hold on. Then I went up to Michigan Tech, which is way up north. It was like a 12-hour drive to get up there. And why did I go into chemical engineering? Well, I really liked chemistry when I got to high school. And when I was younger in junior high, I thought like maybe environmentalist would be great to do. And then I got into chemistry. I thought that was a lot of fun. I wasn't like this top A student in chemistry or math, but I worked hard and I did pretty well. And so then I went to Michigan Tech and I got my chemical engineering degree, and I met my husband, Randy. He's a civil engineer. And we have 3 kids and they're grown, and I have 2 grandsons there on my lap, you can see, and my two kids here, Joel and Hannah. And you know what I've learned about engineering over the years is that, you know, you might go into engineering, think you're going to be just an engineer, but there are so many different things you can do with that degree. It's so flexible, and I wish I would have known that when I was younger, just all the different things you can do. You can be in business, law, you can be in marketing, you're going to hear about sales, you can do customer service, you're going to hear about. So that's why I went into engineering. So I'm trying to move forward here. Okay, so here's another little video on that. Oh.
The world of prosthetic limbs has been making strides for some time now, but the newest versions are beginning to work a little more like this. That is, controlled by the mind of the person sporting the bionic limb. Researchers at the Rehabilitation Institute of Chicago have, for the first time, unveiled a prosthetic leg controlled by the human brain. Okay, so it looks more like a robot wearing a flip-flop than RoboCop, but it works more like a human leg than ever before, combining thoughts and neural signals to produce movement. Zach Vader, who lost part of his right leg in a motorcycle accident 4 years ago, has been testing the new design.
I seamlessly walk up to a set of stairs and just go up foot over foot up the stairs like you do. Whereas with my normal prosthetic, I kind of have to drag it behind me as I go up the stairs.
The leg, which was built thanks to $8 million in funding from the U.S. Army, works by redirecting nerves headed to the damaged muscle, to the hamstrings, and a nearby sensor that reads what the nerves are communicating. Then it does whatever your thoughts tell it to do.
Zach has been rewired.
All right. And Kyle, if you could just keep an eye on, I have 2 dogs here and I cannot predict sometimes when they're going to bark, and I can't find my mute really quickly here. So if you need to mute me, go ahead. So in that video, you just saw, the prosthetic device, and so I do 3D printing. I work in that group at Caterpillar, and all kinds of people use 3D printers to make prosthetics these days. So that's an area that you can use with engineering. Also, electrical, probably engineers have to do with that, and as well, for sure, as mechanical engineers. Lots of engineering goes into a prosthetic, for example, from that. Another thing we wanted to touch on is that, you can make, so with just a bachelor 4-year degree, you can make pretty good money, an average of over $60,000 a year. And, I know sometimes it's hard to imagine, like, how much is $60,000? You have to pay a lot of taxes with that, but you also can buy a lot of fun things. You can, a car, you can have a nice car. I think that's a video game system there. So it just, going into engineering will help you, be able to have a pretty, good life, I guess, if you, watch your budget and things like that. And if you like what you're doing, that comment, if you like what you're doing, then you're never working again, because it doesn't seem like a job. So every day is not like that, but plenty of days are where you just enjoy what you're doing and you don't feel like you're at work. So what does being an engineer mean? This process here is something that in engineering, we do it a lot. We ask questions. Why is something, what do we need to have as an end result? Or why is something not functioning how we want it? And then we have to think about ideas to maybe improve it. So that, imagine we'll have meetings where we brainstorm different ideas. And then we make a plan. Let's get a test plan to see if we can check out different situations to improve something. And then we make it. So creating, in my group, 3D printing, lots of people come to us to create a sample part with their new idea. And then, you make your, let's say, your new idea, and does it work? Is it an improvement? And if it is, then you go ahead and you implement that new idea. Ursula is going to say something about how this can be used in other examples. So Ursula. Oh,
Sorry
Ursula?
to go back to that. It's hard to use my mouse at the same time. So, so hopefully everybody can hear me okay. So one thing that I noticed about this is that when I try to explain this to people and how this is definitely the engineering design process and what we use when we try to improve something that maybe works, sort of well, but then we want to come back and make it really amazing. Actually, with everything in your life, you just ask yourself a question: what is the problem in your life? Generally, if you go through it and brainstorm some kind of solution to it, kind of work out a plan, have to put that plan into action. Maybe you have to test out some different things. One of the examples I used when I was talking to Lisa is, let's say you don't have a job, right? Just ask yourself, okay, so I don't have a job, what do I do about it? And you could brainstorm ideas, right? So you could, create a resume, go look for a job. You could decide that you have an education gap and you should go back to school, maybe. There's lots of different things that you can do there. So use that in life too. That's all I would say. So.
Thanks, Ursula. So I'm trying to go to the next slide here. I don't know that I'm controlling. It says I am. Okay, so this is for chemical engineering, and that's what it's my degree. I don't do a ton of chemical engineering, but I do use the materials information that I learned about. But in general, like, what does a chemical engineer do? And you can see this picture of this young woman here. So all that lab equipment, I loved working in chemistry lab. Actually, that was very interesting to me. And so if you think about just about everything that you touch, plastic or metal or what, but think of all the plastic things in your life. I have a computer mouse in front of me that's made out of plastic. Where does that come from? And I'll show you in a minute where it comes from. But we would, for our degree, we would design a facility that would take oil from the ground and turn it into plastic, maybe. That might be one thing. Or take some other compound and turn it into an additive that goes into gasoline that makes it burn cleaner in your car engine, so you don't have all the pollutants. Or maybe we would take something and turn it into a medicine that will make you feel better. So chemical engineers, they do all kinds of things. So they take a material and they heat it, they maybe put it under pressure, they boil it, whatever they need to do to it to get to a final okay. All right, we'll try again. So all these things here, I worked in a paper and pulp plant right after I graduated college. That map I showed you way up in the UP, there was a paper mill right on Lake Superior. That's where I worked for about 4 years. Medicine, I mentioned, we make medicine. Now, when I first wanted to go into, what first brought me into chemical engineering is I like chemistry. And actually I thought about going into chemistry and being a chemist. Well, my sister is a geological engineer and she said, no, if that's what happens when UPS goes down my street. So a chemist would be the person usually that would run some of the tests on those things to figure out how well they are, how clean they are, or maybe water tests to see if you're getting all the chemicals out. So chemists, they do a lot of that lab work behind the scenes. Okay, so here's a picture of a young woman who is in front of a refinery, and actually one of my friends in college, that's what she did right out of school. She went and worked at a refinery and she would go troubleshoot. She trained for 2 years, and they sent her all over the world to go troubleshoot refineries. So if it wasn't functioning right or separating the products in the oil properly, she had to figure out how to fix it. So what is she doing? Maybe she's trying to make it safer. There are all kinds of things that could happen if it doesn't function well to make this be very unsafe. She might be troubleshooting, she might be looking for a leak to make sure everything runs well. And then that chemist that I mentioned before, they might be running those tests and giving her the data so she can analyze it and see what she needs to do to fix it. So again, like as I said, we make new materials, we have pharmaceuticals. That's a big field that wasn't there quite as much when I was younger. I mean, there's so many new medicines and things like that in the last 30 years. But other things that you can do with engineering, and specifically chemical engineering, marketing, sometimes when you are an engineer, you really understand all the technical that goes into it. So when you have to go talk to a doctor, maybe, and you're trying to sell them a new medicine, it's good to know all that technical information. Accounting, you'd be surprised how many engineers kind of end up really learning a lot of accounting and doing the business end of things. And again, those chemists, they do all the testing to make sure things are right. And that's kind of what you see there. You see this gal, she's got her safety equipment, excuse me, her goggles, her gloves, that's all very important. She's got a hard hat on, maybe she's standing under something that's a safety risk. And so here's an example of a distillation column. This is something like when I was in college, we had one of our labs actually was a small distillation column. But how they function is, when you put oil in them, you use heat to separate oil into many different products. And you can see there that there's quite a few different products depending on the density of it. So here you see some of the gasoline that goes in your car, some petroleum gas, and then also there's diesel. That's the kind of fuel generally that Caterpillar uses for our machines. And that's another example. You can kind of see how it functions there. It boils up and then the other stuff comes out and comes back down, and that's how it's separated. And then you can extract that way. So it was kind of fun actually to do that in school. And I wanted to put a picture of a refinery that maybe you drive by when you go up to Chicago, possibly. This is on I-55 near Joliet. People probably drive by all the time and see that and really don't know what it is. All that white, what people probably may think is smoke, a lot of this is actually steam and is probably quite clean. But that's some of the testing that is done too, is this clean, because it should be. And if it's not, then somebody needs to go in and work on some equipment to help make it clean. So does anybody have any questions on chemical engineering or chemists? And if not, we will move on. I do want to point out a safety thing. Ursula and I were looking at this. So it's great. She's got her glasses on. She's got her hard hat. But if she were out here working, she should have her hair tied back, because that's a big safety risk right there. Is if you're out working, you should have your hair tied back. So, and paying attention to what you're working on. All right. So I'm going to pass it over to Samya. And Samya, I'm moving the slides forward, so just let me know when to move on, and I'm going to go ahead and mute.
Okay, thanks, Lisa. So as I said earlier, I'm an electrical engineer. I work in Caterpillar. I work at Caterpillar, and I've been in Caterpillar for about 10 years now. So currently I work as a controls engineer. I'll get into the details of it later. I was, as you can see, I'm an immigrant. I have a thick accent. You can make that out. I was born and raised in Bangalore, Karnataka, India. And as you can see in the right-hand top corner there, my journey took me thousands of miles from where I grew up, and went to my college and I moved to Chicago to get my master's in electrical and computer engineering at University of Illinois, Chicago. Right now I'm in Peoria, and I'm married, and I have 2 kids, a 4 and a 2-year-old. As you can see in some of those pictures there, yeah, we have fun. One of the pictures actually shows us checking out the solar eclipse, where I had some glasses on there, by the way. And a couple of pictures there have me going on field trips with kids from Quest Charter Academy and a few other schools that I volunteer at. So I've had a lot of fun so far, but at home, I enjoy making experiment kits like the Mars buggy that you see there. And I'm also into alternate energy research. We have about 28 solar panels on our roof, and I track how much energy we make. And as an electrical engineer, especially how the surge happens, how you go down, that interests me a lot. So my husband and I both are totally into it. So that's a common thing we have between us. And I build stuff for my kids, as I said, at play kits, and sometimes I see what interests my toddler, my 4-year-old, and sometimes I make similar stuff, or I come up with similar ideas for some of the volunteering work that I do. Yeah, as you can see there, I have written down that I am pretty stubborn, and usually I go after what I want, and that's a great thing that can serve you anywhere and any time in life. It can get you out of a lot of really low points, or you can pull yourself out of anything. You have to pursue what you want to, where you want to be. Next slide, Lisa. So this actually is a truck, a 797 truck in somewhere in a proving ground. The picture on the right that you see is an emission module. What an emission module is it's a big hunking piece of iron that's placed at the exhaust of an engine, at the outside of the engine. And that goes where the arrow is pointing in the truck. So, and that helps clean some of the bad stuff that comes from the exhaust of a diesel engine. That's what I've worked on for the past 5 years. And I've been, one way or another, I've been involved in the development of this product, this emission module product within Caterpillar for the past 10 years. So what I learned in electrical engineering school is everything from basics of how electrical circuits work, how components work. I recall that, when I used to be in the lab, I used to smell a lot of burning and, burnt plastic smell of resistors and MOSFETs, which is a type of an electrical component. It's a transistor, and LED switches. I also learned how, antennae work, the big hunting, you used to see dishes out there, how they convert signals and transmit signals to satellites, how signals you receive or send can be processed in your computer, how can memories in computers and chips within your cell phones and all kinds of controllers that you can't, if you take apart your cell phone or, it could be like an old big piece of any electronics, you can, if you take it apart using a Phillips screwdriver, you can tell how much electric circuitry goes in that. And I also learned a lot of coding. Today I write code to turn switches and sensors on and off, and a lot of valves, air valves, or sort of like a level valve that has to open and close for the emission module that I call out here, that is pictured here. It comes on with a controller, and it turns on valves that allows a chemical called DEF, or diesel emission fluid, which is basically nothing but urea and water. It squirts it and puts it into that big hunking module that you see that's lifted by the crane, and it has ceramic bricks in it. And there's a chemical reaction that happens, and the air gets cleaner at this point. It removes nitrogen-based pollutants like NOx or nitrogen dioxide. And this nitrogen dioxide actually, nitrogen-based gases actually cause acid rain. And some of the modules that I design or write code for also help remove soot from the air. So the air that you're breathing is cleaner because of these modules that we develop. And overall fuel consumption has also gone down because of the development that has happened over the past 15 years in this field. So fuel efficient cars and heavy mobile equipment that you see, or road equipment that you see, it's all because of some of the development and engineering that's going on in this space. Otherwise, automotive companies would never have invested in this technology, but because there is such a need and requirement from everybody to make our air clean, and there are so many people and governments pushing for the air to be clean, this technology is being developed. So next slide, Lisa. Okay, so what's the next frontier, current and next frontier in energy production? This one here, this slide shows how a hydrogen fuel cell works. And how you could have a battery-powered car or a hydrogen-powered vehicle. But solar is something that I'm super passionate about. So how solar energy works is it turns light from the sun into electricity. Solar cells are also called photovoltaic cells. Photo is actually Latin for volt, and voltaic means electricity. So solar cells are put together to make solar panels, and they make grids out of them, or rather an array out of them. Rows and rows of solar panels are created, and solar panels are could be put on your house, the roof of your house, or anywhere where there's a need for, where there's plenty of sun. They can be put up there, and there's a big need for technicians in this field. Actually, that's what the person I work with, who installed solar panels, told me. So, and we'll get to that later, but that's also a big need right now, trade school and technician work. And
Samia.
Yeah, go ahead.
I just want to interrupt for a second and ask you, so basically, as an electrical engineer, they can work, and a technician, electrician, they can work in all these different areas here as an electrical engineer, just to give you an idea. And that's kind of the
Yeah, that's the
that's-
idea there. Yeah, yeah,
that's the
you can.
key there. Is it interested?
Yeah. All of them need to be
Yep.
controlled, and power needs to be managed, and you need to manage how the power that you generate comes out of these different power sources, and distribute it, right, and send them into grids, or put them back into grids. If you've heard, or if you're aware of the recent story of Dallas losing power, of not because they were not a part of the electrical grid, you know how important power distribution is, and how power generation and electrification is critical to maintaining constant power and or consistent power generation. And this is a big part of what electrical engineers do. There are professional engineers as well who get licensed to work in this space, and they can work with a lot of different state governments or state-run facilities and manage this. So this is something that electrical engineers do, and this is actually going to be the next frontier. Electrification everywhere is going to be the next frontier of energy consumption, and this is where we need a lot of people who develop these skills.
Just think about, some of you might be, I don't know if you know, but there's a plant that used to be Mitsubishi. They're building trucks that are going to be electric powered. And, cars, we have electric cars. And so, maybe in another 10 years, most of our vehicles might be electric. So definitely lots of work out there for electricians and electrical engineers. Samia, I'm going to go to the next slide. And I think Adam.
Yep, please. Yes.
Yep. So Adam, do you want to introduce yourself?
Yeah, so I'm Adam Sinclair. I'm a lab support engineer for Caterpillar. I'm from a small town about 50 miles west of Peoria. I grew up small town, kind of hunting, fishing. I do some stuff with horses and that. I started with CAT about 16 years ago as a intern while I was going to college at Spoon River College. I went through the diesel tractor technology program there. So I have a 2-year associate's degree. After my internship, I started as a mechanic. I was a mechanic for about 8 years, and then I went to the lab support engineer role. With that, I've worked on some of the stuff like Somia has talked about, engine testing, emissions testing, stuff like that. The last few years, I've been involved with just package genset testing.
So Adam, I have a question for you about your program. When you were going to Spoon River, and then you mentioned you have an on-the-job training. Is that part of the 2 years, or is that after you graduate?
That's part of it.
So the costs are fairly reasonable then to do that, because you're going
yeah. So while you're in a school like that, I think I didn't go to ICC. Maybe Sam can talk about that. But so you buy tools to be a mechanic when you start school, and like you can get that through you can get money for that through student loans. And then after my first semester, I actually started at a John Deere dealership and worked as a mechanic there when I wasn't actually in school.
That's great.
And then I started with CAT as an intern that next summer.
Well, we're glad.
But yeah, I was able to. Yeah, but yeah, I was able to pay for my school by working the entire time.
Yeah, that's great. Well, we'll go to the next slide so you can talk about what you do. There you go.
Yeah, so these are just a few examples of projects I've worked on just through the years. Different things, packages I've even had. But you know, the world runs on electricity, so we have backup emergency power for hospitals all over the world. Different products power offshore drilling rigs, off-site, you know, out in the middle of nowhere, oil rigs, and even power plants that are just, you know, purely our CAT diesel engines powering maybe an entire island.
Yeah.
And we even, I can't talk about it a whole lot, but we do, you know, develop backup power for like nuclear submarines for the Navy.
Yeah. Yeah, actually, just it's interesting that the defense industry is actually Caterpillar's largest customer, which I didn't really know that, but I learned that we sell engines to the Navy also, some of these large engines, and he's referring to generators, but we also have the engine side of things too. So I think we're going to move on to the next presenter, which I believe, thank you, Adam, is Nicole. So Nicole.
Hi there. So yeah, I'm Nicole Warnstead. So I started at Caterpillar actually as an intern, a marketing intern actually, in 2019. And so I did that part-time while I was in school at Bradley, which while I was at Bradley, so I was there through 2019. And then I graduated in May of 2020 with a mechanical engineering degree. And then from there, I started working full-time at Caterpillar and became an electric power marketing rep, which is more like an electric power sales rep is probably a better term. And I've been doing that since July 2020, virtually actually, and we'll hopefully be back to the office soon. And so before I went to Bradley, I actually went to a community college as well. So I used to live in the suburbs of Chicago. And so I went to community college there, which is kind of, the William Mary Harper College is very similar to ICC in the fact that it's a very good community college, and I learned a lot there. And it kind of helped me decide what my path for engineering. And so I'm currently in Peoria. I have some photos of, so it's me and my boyfriend when we lived together there, and those are our two cats. And that was some pictures from when I graduated from Bradley. Some things I do in my free time, I really like exercising, and I like to eat a lot. So I usually eat a lot and then, you know, exercise it off. And then I like to also play video games in my free time as well. And I used to swim and play water polo in college, but I haven't really found a decent pool out here. So eventually we'll get back into that once I can do that. And so I wanted to touch a bit on why I chose engineering. So I actually chose it because I knew I kind of wanted, it's funny, I don't do this in my day-to-day job now, but I really wanted to like make things and work with my hands. And so that's why, so my dad actually suggested, he's like, well, why don't you look into engineering? You know, you can, they pay really well to do things like that with an engineering degree. And so that's kind of how I started my path to engineering. I actually had some high school classes that introduced me to different aspects of engineering as well. And so that kind of led me down that path. And so every engineer I've ever met has told me, and we've already kind of touched on this a bit, but you learn in engineering school problem solving skills. And so that can be used for pretty much any job you could imagine, as we've kind of already touched on a bit. And I'll talk a bit more about that as I go through, because obviously I'm not working as a traditional engineer in this current role. But there's so many opportunities with engineering. It's pretty crazy. And so I want to talk a bit about mechanical engineering and so this was actually the main reason I chose mechanical engineering was because it's really broad. Because I initially was thinking maybe electrical, but I just saw that with mechanical, I wasn't entirely sure what I wanted to do with engineering. And I knew that with mechanical, there's so many different things that connect and work with a mechanical engineering degree. It's really cool. And so its official term is just the study of objects and systems in motion. And so when I was in school, some core study areas I had were mechanics, that's basically just a type of physics concerned with the motion of physical objects. You also learn about dynamics, so that's the relationship between different things in motion, and then how it's causes of that motion. And then you also have thermodynamics, so that's physics that deals with like heat, work, temperature, and then that relates to like energy. So you learn about that, and then material science as well. So that's just like learning about different or new materials, or finding new materials and things like that, or designing with them as well. And then structural analysis, which is a determination of effects of loads, so different loads on physical structures. And then you also learn a bit about electricity. So it's a huge list of things, and that's because you learn a little bit about everything with a mechanical engineering, and there's a bit of that crossover with the other degrees mentioned previously as well. So there's a lot going on there. And so as we've already kind of talked about, you can pretty much find mechanical engineers in like any industry you could think of. A big one I know is automotive. I knew a lot of engineers who got into that because of they were really into cars, and so you'll meet a lot of engineers like that in mechanical engineering school. Aerospace, think just anything that moves, right? Biotechnology, that's I mean, Lisa showed that video already, but it's just anything that moves. You can study mechanical engineering, but then also have like a biology concentration. So you can work with different medical things to have that be your path. Maybe you've got computers, electronics, microelectrical, mechanical. That's a kind of a little bit of all of that. Energy conversion, robotics, animation, manufacturing. Like it's really endless what you can do. And as I already kind of mentioned, because you learn all those, you get creative skills, you get analytics tools, you get all these different things. It helps you to work in different areas. So I think Lisa already kind of mentioned, banking, financing, medicine, law, consulting, management, and I actually work in marketing at Caterpillar. And so on a day-to-day basis, what my job is basically, so I'm considered a sales rep. So I am like a liaison between Caterpillar, and then Caterpillar has what's called the dealer network. So those are the dealers, or are the people who actually do the selling of like our, so I'm like with electric power. So like they sell generators. And so what I do is I work with the dealers to make sure that there's, a flow and a feedback between Caterpillar and their dealers, and making sure that everything's being sold correctly and there's no problems there.
So Nicole, for example, would you go to the dealers maybe as Samya and Adam are working on a new offering, and you'd go say, hey, we have this new product that's coming out on the market pretty soon. I'm really excited about it. Yeah. I mean, do you do that kind of work, or do you like go answer technical questions for them because you've got the engineering background? Right. So yeah. So what kind of tell us what, if you go to talk to a dealer, like what might one conversation be about? Yeah, so like for instance, let's say we have a new powered node coming out for our generators. And it's probably coming out because we talked to our dealers, and our dealers said, oh, we're missing this product. Like we need a better offering at this product or at this power node or whatever. And so that goes back to Caterpillar engineers, and the Caterpillar engineers find a way to make that product, and hopefully at a reasonable price that we can sell it at. And then that comes back to us. And then so we get all that information. So what we have to do is kind of work to make different materials that explain all that stuff to the dealers, and make sure, and then give them a bunch of resources as well, to make sure that they understand the new product as well. They understand the pricing. They understand how we're trying to sell it. Maybe there's different discounts we give out because it's a new product. And so that's something that we, as a sales rep, would approve. And so, so we just basically explain all the different things going on and make sure that they're up to date on all our products coming out. Just any questions that they have about anything pretty much is how we help them out. And so, and each of us has our own like territory of dealers. So we're just focused on like
certain dealers and their different pain points, and if you're in different areas of the country, for example, they're focused on different things. Like people buy like in hurricane areas, they're more focused on products that they want to make sure that they have a lot of backup generators and certain types of generators that can handle the hurricanes and things like that.
All right, well, I think we're going to move on to Ursula. And so does anybody have any questions for Nicole? You know, she's in a little bit different niche as far as being in marketing for Caterpillar.
I know Ursula will also talk more about mechanical engineering as well.
Yes, she will. Yep. All right, I'm going to move on then, Ursula. Maybe. Actually, she's going to take control herself, I think.
I sure am. Hopefully that worked all right. Okay. Hopefully everybody can hear me all right. So my name's Ursula. I grew up on a dairy farm in Wisconsin, literally surrounded by cows. The only reason really that I was able to go to college at all was because of a basketball scholarship. I super love dachshunds. I love science. I love trail running. Basically any kind of new experience where I can get out and explore the outdoors. I'm really game for that. I graduated with a Bachelor of Science in Mechanical Engineering from University of Wisconsin-Platteville. It's a smaller, one of the satellite schools in Wisconsin. And I also am currently outreach co-chair with Society of Women Engineers in Central Illinois. There we go. Okay, so with the Society of Women Engineers here locally, I get involved a lot of outreach curriculums and at various places. When we used to go to schools, we could be able to go into schools and have experiments that we would show them. However, obviously since COVID, we've had to reel that back a little bit. We're just getting started to do some of that stuff again. Some of these pictures, there's a big date range here. So back when we could go and do these programs without masks, we would do things like at the Dream Center. We'd learn construction techniques to build gingerbread houses, or we'd make pumpkins around Halloween time, and we'd show chemical reactions. So to get kids interested in chemistry a little bit there. And just recently, actually, we were able to get back into Dream Center and see the giant bubble recipe there. We made that from scratch. That's our own recipe that we created there on site. So we work with a lot of other groups that have kind of that like-minded, hey, we need to generate a group of interested people in STEM careers. So places like GEMS, that's Girls in Engineering, Math, and Science, are out of Morton. So we work with them. We work with the Riverfront Museum. We work with the 4-H here in Central Illinois. We also work with agencies like the Girl Scouts of America too. So those are all really good resources if you're interested in science careers. They all have things like the Girl Scouts have STEM badges now if you get involved in Girl Scouts. Something for us, if you want to join SWE Next, that's a group that's part of it's a club that's free for kids to sign up. You have to be 18 and under. If you're under 13, your parents will have to help get you signed up, but all you need is an email address for that. There's no solicitation with that. So it's just scholarship info. It's got fun engineering and science challenges that come right to your inbox. And be sure to use code SILSWE, that's CILSWE, so that they know that you came from us. You got it recommended from us. So the link will be there when we send this out to people, so you can use that if you want to do that.
Ursula, I just want to step in here.
Sure.
So as a CASA supervisor, you know, I sent this information to my families and they were able to sign up. So, you know, it doesn't have to be a parent. It can be a foster parent or a guardian or whoever, if you're a younger child. And if you're over the age of 13, you can do it yourself. So I just want to know that clarification.
Thanks, Lisa.
Mm-hmm.
Okay, so kind of like Nicole talked about why she became a mechanical engineer. For me, it was really about my environment that I grew up in. A couple of things around me, most of the time were broken on this dairy farm. That isn't a picture from my farm, but it sure could be. We had a lot of tractors that looked just like that with tires that were just, you know, sagging, and maybe the engine didn't work for whatever reason, or the gears were all busted inside it. So we were always fixing things. And I think it generated something in me that really got me interested in that kind of thing. Also, you see that airplane there, that's an A-10 Warthog. It's obviously a military plane, but it flies really low. And something that I've had confirmed here now by pilots that I've met as an adult is that they like to fly really low and scare cows. So on the dairy farm, that was kind of a target. So I lived near this Air Force base and they'd love to fly by and the cows would just go running around like crazy. So one of the things that was kind of neat about growing up in the era I grew up in is that being able to break the sound barrier over occupied areas was fine. And so if you haven't heard that, I'd like you to kind of experience that. And for me, it was very thrilling. So if you got headsets on, you might want to turn them down just a second. I'll give you just a moment to do that before I play the video. And this is just a little clip of something of what it was like to grow up in a dairy farm in Wisconsin. So that was something we heard on a regular basis. We in fact would have windows broken in the barn and things because they would do that. They would go over and it would make such a loud boom. So to me, I thought that was thrilling as a kid, even though it was breaking windows. Okay, so now what do I do for a living? So long time since I grew up on a farm in Wisconsin. For the last about 13 years, I've been working in engine development. When I first started out with Caterpillar, I used a computer to design parts that we would create and build and assemble onto machines. But I moved into engine testing. And engine testing, I realized, was really a good fit for my interest in being able to work with things with my hands. Again, I think it's got a little bit of a thrilling aspect to it for what we do. And of course, there's that kind of feel-good part of you that you're making power, you're making equipment that can do really big jobs in the world. So for the previous past 10 years, I had a job that looks something like this. So again, hopefully your headsets aren't turned up too loud.
So Ursula, before you play that,
sure.
So these engines, it's hard to tell in these pictures, but the engines that we've been talking about are about as big as my kitchen or more. I don't have a kitchen, so, but they're huge. They're really big.
Yeah. They're really big. The 3500 engines are about as big as your kitchen. The one here I'm going to show, this isn't a Caterpillar test cell. This could probably fit in your bathroom, but it would take up the whole bathroom, like the shower too, if you got a shower there. Okay, you ready? All right. Okay, so you can see that was kind of an interesting test, right? It was a test that everything got broken. And so sometimes that's what happens in the lab. The whole idea behind this is that we want to break these things in a test cell so that they don't do that out in the field for a person who bought a piece of equipment or a machine and they're running a job, and it's really important. So we have to take very careful setup procedures to be able to put an engine into a cell, be able to even just install it, mount it, secure it so that it doesn't, vibrate out of its location, and then actually add something, a very special piece of equipment to provide the resistance on the engine, like it's kind of in a vehicle, like it still has the drivetrain and things that are on an engine. So that's called a dynamometer. And so we have very special test cells that do that very thing. Okay, so just a little bit more about that 3500. You might not be aware of what that is. So that is a particular size of engine. And just to get a handle on what kind of applications that the 3500 engine would go in. Now, as you go through this next video clip, realize that some of these have more than one of these in them. So they're very big engines. Like Lisa said, maybe these would take up your whole kitchen. They're very big pieces of equipment, very big power systems. And so these are some really good applications all over the place. So Adam talked about the huge variety of things that we make power for. This will give you a better idea. Thanks.
So this video is showing things that these large engines go into.
You can see that they have engine applications all over. So such a broad range of things that they do. A lot of these generators that we like to talk about are an engine incorporated into a system that provides backup power. So if power goes out, or maybe there's a country that's had severe hurricane problems and they need power, generators will do that for them. They'll be able to provide that power as a system in some of these remote places. And engines are in places that you don't necessarily think they're located. So even in big cities, like right in the downtown heart of a big city, in fact, when they've rebuilt the World Trade Centers in downtown Manhattan, actually there's a lot of electric power that starts with an engine. And so if you would look here, I'm gonna use my cursor, and you guys can see my cursor maybe. And if you would look on the sides of these buildings, there's slits. It's not all glass. Some of these places are actually open, and they're actually meant to be engine exhaust vents. And so you literally do have engines running in here. And so about every 10 floors, you'll see those same slits, and that's an engine room. So most people wouldn't necessarily be walking down the street in a big city looking for an engine like that, but they're there, and actually they're in those big tall buildings too.
So Ursula, I have a question.
Sure.
So can you kind of explain real quick? So you have engines that make cars or machines or rails move, but then we also have engines that create electricity. And how are those different, or how are they the same? How do you get an engine to make electricity?
So that's a good question. so
I'm a
what
chemical engineer. I don't know. So you tell me.
Exactly. So if you took your basic engine before it's packaged into anything, that creates rotational mechanical motion. And so lots of times that's just driving a drive shaft, like in a truck or something. But if you take that rotational motion and apply it to coils in a big generator package, you can actually create electricity. Okay. And so that rotational energy is actually turned into electrical energy, and then they can use that just like you would any electricity. Does that help?
Yeah. And so like I know that I've seen that we have sometime, if you're driving on the highway, you can see a cat generator. You'll see the Caterpillar rectangle cube of something. It's a generator, and it's sitting on a landfill, and it is burning. It is running and making electricity from the gases that are given off, the natural gas that is created from the landfill.
Yep, that's a special mixture. That's a special added package that we have. So we talked about diesel fuel, and we use that for some of our engines, but a lot of cleaner burning fuels are getting to be very popular. And like you said, natural gas is one of those.
Yeah. And I know that we have those in all around the world to help countries generate electricity in places that would be maybe difficult for them to get electricity, because you have to have lines and everything that transfers it. So you can put one of these generators, and maybe it can run off of solar energy or the natural gas coming off of a landfill possibly, or whatever. So I just wanted to throw that in. Go ahead.
Yeah. So Samya and Adam had talked about the battery systems. And so if you look at power from kind of a system perspective and not just the pieces, beyond just having maybe a generator that takes mechanical energy and turns it into electrical energy, you might want other kinds of electrical energy sources that produce electricity as well. And so that would be maybe wind or solar or whatever. So all of those would maybe the same goal, different ways to get it.
Okay, so let's keep going. We have about 5
Okay,
minutes.
yep, nearly finished here. I just wanted to hit on a couple other types of jobs that are at the tech center. So we have what we do in our test cells called calibration. We have a very exacting lab. So the measurements we make a lot of data. We want to make sure that data is very good quality and very accurate. And so we have to meet something that's an international standard actually for a laboratory certification. That's ISO 17025. And so we have people that work just to help us maintain that in our test cells so that our data is good quality. We also have people that work on emissions equipment. Now, what emissions equipment would be that we measure everything that comes out of these engines, whether it's the fluid that's flowing from them or into them, or if it's temperatures or pressures. It's also in the exhaust. So anything in the exhaust, whether it be particles or whether it be the gas that comes out of the exhaust pipe, we want to know what that's made of. So we use emissions equipment. And of course, we need people to set up and repair those when they're broken to be able to clean them out when they need repair. And instrumentation would apply to anybody who works in the pieces of equipment that help us make all those measurements. And so instrumentation is just a really big collective word for people that help us measure temperature. You know, sort of like you have a thermometer at home, but we have special types of way to do that in the lab. Pressure, maybe you have a barometer at home that enables you to measure atmospheric pressure. So we have special types of things that do that in the lab as well. So something I want to point out, you know, Lisa talked about, you know, math wasn't really her driving thing when she was going to school and choosing a career. In talking with one of the engineering managers in my building, his name is Rick Wilson, because I got a quote here from him. I want to just read that to you guys. So I always tell people to read books and to learn how to write well. As you're aware, getting something accomplished in our lab takes the help and participation of many different people. That requires effective communication and the development of honest and positive relationships. And I think that goes in just about any career that you would choose. It's backed up a little bit here by LinkedIn research. They said the #1 soft skill is communication across the board. And so with that, maybe Lisa, do you want to take over for the rest of this?
Sure. Yeah, I just wanted to point out there on Ursula's list, you know, I think a lot of people have a perception to be an engineer, you have to be a superstar in math or science. And definitely, you know, you got to enjoy doing math to some degree. And I did, but I had to work at it. And I guess a lot of the skills here, they're truly important to all kinds of jobs, but especially engineering too, are things that we very much have control over if we just work at it a little bit. So like you see being punctual, so being on time, being organized, how well you talk. And, you know, I used to be super nervous about speaking. If I would have been doing this 15 years ago, I would have been very nervous. I'm not nervous right now at all because I've had lots of practice. So it's okay to be nervous about doing things. You know, you just want to practice. And creativity, you know, maybe you enjoy drawing or doodling or creating or however, whatever you like to do. Maybe you play video games and you like to do different things with those. You know, you can see a lot of these skills are not necessarily super technical. And so that you don't have to be a superstar, you just kind of have to be interested really in the topic. And, you know, you can practice. You know, I took chemistry a few times, and I mean, I had decent grades, and every time I took it, I learned more and more. And I was tutoring chemistry in college because I took it and I understood it. And so I guess I just want to get across it. I think people have an idea about engineers that, you know, you have to be all straight A student. And I don't think, some may have been all straight A students, but certainly not everybody is. And so I just want to say, you know, if you're interested and you in solving problems and maybe you like to do puzzles and things like that, you know, consider a STEM career, an engineering career. And let's see, I think I have, did you give me back control, Ursula?
I hope I did. Yeah, give it a try.
Yeah, I'm trying. Sometimes it takes a minute here.
Yeah, to click into it maybe.
Yeah, I am clicking. It's not going. There we go. So these are still on mechanical engineering, but these are some of the different companies that hire. So you see Harley Davidson, or if there's any motorcycle fans out there, or, you know, Northrop Grumman is a defense industry. Apple, we all know Apple probably, Motorola for phones, Caterpillar. We've talked a lot about these different areas. This is mechanical, but I would say in my field, like I could work at a lot of those places too, as could an electrical engineer. And we have, I want to give Sam a chance here to talk about the diesel, his opportunities he's had at ICC. I don't know, I guess you can explain more about, we do have a diesel technician program. I think that is actually different from what Sam has done. But we do have that, and there's a link in this presentation if you're interested in it. And really, you know, it's a great career, I would say, because we always need people to help work on our equipment. So go ahead, Sam. I'm trying to get up to your slide here. There we go.
Alrighty, so yeah, my name's Sam Chadwick, and I went through the Caterpillar Think Big program at ICC. So that's a 2-year associate's degree program, and I'll touch a little bit more on that here in a second. But some of my hobbies are hunting, fishing, cars, snowboarding, traveling, and doing all sorts of different stuff outside. Big outdoors guy, but how I ended up where I am now is between the Think Big and Think Bigger program, and then internship with Caterpillar Defense. And then now I'm in the marketing rep development program, and I'm going to be a global construction and infrastructure service tech rep once I eventually get placed in the field. So kind of going back to the Think Big program at ICC, the 2-year program is really cool because it's not all 2 years of straight class. It's actually 2 years of 8 weeks on campus, learning about all the different systems on CAT machines, and it does cross over to other brands of equipment as well. And then the following 8 weeks are going to a dealership that you partnered with for the program, and you do an internship with them. On that internship, you're actually working as a service technician, turning wrenches, fixing machines, and doing what you'll be doing full-time after the program. So the nice part about that as well is most of those internships are paid, and when you're in school, you can almost make enough money to pay for your entire 2-year education. And at the same time, since it's with Illinois Central College, you can use the Peoria Promise, and if you're in the Peoria area, and most of the time get your tuition paid for through that. It's right next door to it as well. I'll kind of talk about the other diesel program at ICC. It's similar in the fact that it's 2 years. I don't know as much about how it's all planned out, but they focus a lot more on highway and agricultural equipment than construction equipment. So that's the main difference in the two programs. Is the Caterpillar program is CAT specific, but the DPEP program, as they call it, will cover a wide range of brands and things that you can go into.
That's a great point, Chad. My coworker in my 3D printing group, he is a farmer. Actually, he still is a farmer. Just finished planted corn and soybeans. And he joined that program you're just referring to because he wanted to learn how to fix his equipment. And in that program, somehow he joined on with Caterpillar, and now he's been working at Caterpillar all these years, and he's a farmer, and it's a nice combination. He's able to do both, actually. And like you said, it's not that specific. It's any kind of probably diesel, engine that goes into all kinds of different equipment. So.
Yep.
Do I have let's see, I feel like, did we have another slide? Oh yeah, we do. We have some great
slides.
Here.
So this is just a couple of pictures of something that I got involved with during my time at the dealership on one of my internships. And this was a certified powertrain rebuild on a Caterpillar wheel loader. And on this rebuild, essentially what we did is pull the machine in with a whole lot of hours on it, basically at the end of the life of the engine and some of the other components we were working on, and pull it all the way apart to almost the bare frame. On this one, we just had a few hydraulic hoses and wiring harnesses that were left on there. But other than that, everything came out. And on the left side of the screen,
I'm sorry.
Oh,
sorry.
No, sorry. That's the engine and transmission after we just removed it. And one of the things you do with this is you'll tear it down, put all new internal components inside the engine. And on the following slide, like we'll see, when we're done with the project or this rebuild, the machine looks brand new. I mean, we repaint them, put new stickers on them, and it's essentially a whole new machine, as you can see here, which is really nice for the customer because the cost of doing a rebuild is quite a bit less than buying a new machine of the same size. So it just extends the life of that machine even longer than a traditional use of it.
And I believe, I know like in our engine reman program, if they buy a rebuild, they have the same warranty as a brand new engine, which is amazing, really.
Yep.
So I do want to just kind of tie everything up here together. Thank you, Sam. So when you look at all of our team that is presented, and thank you very much, everybody. You know, like on my end, in my 3D printing group, we make products that people can check out while they're thinking of new ideas. We also make really old parts that you can't get anymore. We do a little bit of both. And then Ursula and Adam and Samya all test and design products to make sure they're going to be ready for the market, or make sure they're improved, or they're safe, or they're making clean exhaust, whatever it is. And then Nicole, she also goes out and finds out from the customers, what do they need, what do they want, and she takes that message back to our engineers back here. And then Sam, he also helps improve all that with his customer service. So he'll be working directly with the clients as well, kind of in a different role than Nicole does. And so everybody kind of works together. You know, we're a huge company. We all kind of work together. We may not work together exactly on a team, but everybody kind of comes together to make all the different products that we make. And, you know, so Caterpillar and other similar companies like ours, you know, we make things that help. If you think about like the power outage, or, you know, we can make things that will keep the power going, or gosh, you know, if we've had a tragedy, or, you know, like a hurricane or anything like that, you'll see CAT equipment in there cleaning up, because, you know, that's all you can use to clean up big things, is a big excavator. And so, you know, it's something that we all kind of feel good about when we see, you know, our equipment being used to help people, like in flood situations or other disaster situations. A lot of times it's Caterpillar equipment that's used, or other large equipment companies. And on a final note here, that was a Think Big. So this is included in the slides that will go out to everybody. And if you Googled, you'd find ICC. And, you know, we talked on very specific engineering and technician marketing jobs, but there are other engineering jobs that are also quite interesting and very much available. I would say civil is probably one of the top ones. My husband's a structural. He works on buildings, where he's worked on roads in the past, but he does a lot of building design. Lots of people go into civil engineering. It's if you think about all the work that's going to be needed to be done on infrastructure, bridges, roads, you know, we need engineers working on that. Environmental is sometimes a smaller or a sub version of civil, and sometimes it's its own major. It kind of depends on the university. Biological, you saw there at the beginning, on prosthetics and things like that, medical devices. And then food engineering is a, you know, I think it's kind of an offshoot of chemical engineering maybe, but it also has some biology. But think about all the food you can buy that has had to go through some kind of anything really to get to you at the grocery store. You know, they got to figure out how to get it out of the farm to the grocery store and be healthy and safe. So there's a lot of engineering that goes into that as well. And that's pretty interesting. My nieces both work in that field, and they have a lot of fun jobs. So that is the conclusion of our presentation. Bianca or Kyle, do you have any closing questions?
I don't believe I have any questions. I think everyone explained their areas so well. I haven't seen any questions pop up in our Q&A. If you wanted to do that, now is the opportunity. But in the meantime, I'm just going to repeat kind of what Lisa said, and thanking everyone so much for signing on tonight. We appreciate everything, the time and effort you've put into this today. We cannot wait to share this, not only with who's logged on tonight, but this will also be on our YouTube channel, which is CASA of the 10th. So we will make sure to get that out, and we will share the presentation as well, so everyone can get access to that resource. But I don't see any questions right now. But again, thank you so much to our wonderful panel for all of your information and your time. We really appreciate it. And I think it's going to reach the right people. So if you guys don't have anything, we'll go ahead and wrap this up.
So Bianca, just FYI, or Kyle, you know, if anybody had a question and they want to talk to somebody personally, they can always kind of go through you guys to get information from us. So that goes out to the kids or their volunteers or whoever. So just putting that out there, that we're very available, and just reach out through the organization and we'll be glad to help.
Would love to. Absolutely.
Okay. Yeah, thank you. Well, thanks for giving us the opportunity.
Yes.